Earths and Science, Chapter 1, Earthquakes and Fault. Chapter 2, Understanding Typhoons. Chapter 3, Other Members of the Solar System. Let's focus first from the layers of the Earth. Hi, I'm Earth. I am the third planet from the Sun. My surface is mainly water. I am the planet that can support life, and this is where you humans live. Let's now proceed first for the different layers of the Earth. It is actually composed of different layers, but let's tackle the primary: crust, mantle, and core. First is crust. This layer it might seem too thick, but it actually takes 1% of the Earth's volume. It is considered as the outermost layer of the Earth and where the organisms and we live. This has two types: oceanic crust and continental crust. Oceanic crust is made up of basalt and 6 km thick, while the continental crust are the parts of the crust where continental mountain ranges are found around 30 to 45 km thick. It is also composed of graphite or andesite and basalt. Most earthquakes and volcanic eruptions occur within the crust, particularly along the tectonic plate boundaries and where the crust is the most active and unstable. Let's proceed now with the geological process. Some mechanisms are involved in the process. First is weathering. Next, erosion. And lastly, plate tectonics or the plate movement. Weathering is a process that involves breaking down of rocks and minerals, and here it includes the following agents. First is water, ice, plants, animals, and the changes in temperature. Next process is erosion. Erosion, it is a process in which soil, rock, and other surface materials are worn away, and it is transported by natural forces such as wind and water. Next, plate tectonics. This movement of the tectonic plate affects the seismic activities at different plate boundaries. Lying below the lithosphere is the asthenosphere. Asthenosphere is the ductile part of the Earth, and it is approximately 100 km to 700 km deep from the crust, and it allows the tectonic plate to move over it. Next is mantle. Underneath the crust is the mantle, and it is believed that it covers almost the 84% of the Earth's volume. And the layer is basically composed of peridotite, wherein peridotite is an igneous rock and usually dark-colored coarse green rock, and it sometimes contains diamond. Next is core. Core has two types, inner core and outer core. Earth's core is generally rich in sulfur and iron, and it was discovered by Richard Oldham in 1906. So now, what is outer core? Outer core is the only liquid layer of the Earth, and it is believed that it is responsible for Earth's magnetic field. Next is inner core. Inner core, it is considered as a solid compared to the outer core. The depth of the inner core from Earth's surface make it inaccessible for analysis and studying. And this is why the seismic waves from earthquakes are the primary sources of data to study the core. It was discovered also by Inge Lehmann, a Danish seismologist and geophysicist, in the year 1936. Now, since we already know the layers of the Earth, let's now proceed with the transition zone between the layers of the Earth. First, we can see here the Conrod discontinuity. Conrod discontinuity or the Conrod discontinuity separates the upper and the lower crust. Next is Mohorovicic discontinuity. The transition between the crust and the mantle. Next is Rhabdite discontinuity. This separates the upper mantle and the lower mantle. Next is Gothenburg discontinuity. This is the transition zone between the lower mantle and the outer core. And lastly, Lehmann discontinuity. Lehmann discontinuity layers separating the outer core from the inner core. And that's it. I hope you learned something from me.